So it turns out I lied. There is a 2b. It looks a little bit tricky, but we're gonna work through it. So the first part of 2bi asks us to make this truth table, gate G, using just one delay and or ors. I think that's pretty easy when you realize that y is an or and x is an and. So all we have to do is say here's s, here's t. Let's make an and that will be our x. Let's make an or, and that will be our y. Something like that. I do this really poorly, but that's all you need to do for 2bi, I think. 2bii is a little bit tougher. It says use 3 copies of G. I think it says you have to sort S, T, U to X, Y, Z. So like in increasing order, if we have like 0, 1, 0, this would end up as 0, 0, 1. If we have 1, 1, 0, this would end up as 0, 1, 1. That's a little bit tough. So I think the way I would approach this, I think I'll approach this by trying to come up with sort of expressions I can use for x, y, and z. So x, we know, has to be the and of all 3 of the inputs, right? Because or else they're all just going to get pushed over. When it gets sorted, x will be the only 0 if there, or will be 0 if there are any zeros in my input. So I can express it as the and of st and u, which can be, an and of st and of like. So remember that these are 2 input gates. It can be like the and of and st and u, or any combination like this where I have all 3 of them. This could be ut and s, or us and t. Y is going to be at least 2 of the inputs must be 1, right? So maybe I'll write it as like the or of, so an interesting way we can write this is like or, so we'll write it actually as an and of or st, let's see, and or st u, right? So this gets the case where either s or t and u, and then the only other case is both s and t, right? Maybe I should have drawn a truth table to make this more clear, but basically y is true in 3 cases. If all 3 are inputs, if the later 2, if the first 2, or the outside 2, these are my cases for y. Or s and t and u handles all of them except for t and u. Oh no, sorry, except for s and t. So this one here is the only one not handled by this expression. So I can say something like or this, or and st. Okay. So here I just realized I have an and st and another and st. That might be becoming helpful. Z, we know, oh boy, it's going to be like anything at all. Like the or of st and u. Okay. Oh, wait a second. I have an or of st. What does G output if I give it st, an and st, and an or st? So I see some patterns here that might help me start drawing this. I think it's important to start drawing this, but to start thinking about these before I start drawing. So I'll start off with st, u. Here, it seems like I'm really going to need it, or it would be really helpful to have an and st. Here's my and st and my or st. Okay. So now we want to end up with an and stu. To get that, we can just make another G. Let's pass our and into it. This is going to be my or. And we'll pass u into it. Here we'll get and st and u. So this will be my x. And then here we'll get or we'll get or ST or U. So or ST, U. And this is and ST. Okay, so that handles a couple of our Y cases, right? We have one more gate we can use. We have to be careful about how we use it, that we get both Y and Z from it. Oh boy. So we got X here. X is one of our outputs. We need Z to be the OR of anything. So like the OR of, so here we have OR ST U. Let's think about Y. So we said OR ST U here. We generated that. That's pretty convenient. The other thing we need is this. So this is, and we need and STU. And that's tough. And or STU. Yeah, so this here is this, right? And we need that or and ST. So say we take this guy and our and ST. Oh no, sorry, we wanted or STU. Oh, so this is wrong. This is not an and. Right, this is, oh no, it is an and. Ah, shoot. But we wanted and ST or and or ST U. Oh, it's looking a little bit sketchy here. Let me revise this gate here, I think. Okay, I think maybe I wanted to take this or ST, so we can get an or, an and of or ST and U. So this is going to be and or ST U, and this is going to be and, so this is going to be or ST U, or ST U. Oh, wait a second. Isn't or of ST and U, isn't this Z, right? Oh, look at that. Things are looking up. So here we'll make this, I don't know if you can see that. Make this Z. Now we have our and of or of ST and U, and now we just need an and of ST. And we need these things to be ORed together, so let's pass that into our G gate, pass this into our G gate. Oh, okay. So and ST and or STU, we get the OR of those will be Y. And then is X generated well here? We have and ST going in. And this is and or STU, which means U must be true here, and ST must be true here. So this is X, because it's the and of ST and U. Okay, I think we did it. It's a little bit messy. Really, I think you got to figure out these things sort of first and look for some patterns. Truth table probably would have helped too. I didn't want to spend time doing that, but it maybe saved some time. Would have saved some time if I did it. I hope you followed through some of the. I really felt like I was rambling, staring at this thing for a while there. But I hope it gave you some idea of how to approach this. You really got to play around a little. I don't know if there's a very good, kind of approach that you can just kind of step through to do this. Yeah, I hope that helps some when thinking about circuits. I don't think the problem on the midterm will be this tough, but it would be good to practice on this. And I'll move on to question 3 for real this time.